In this video, we will solve a question on probability that will cover equally likely, exhaustive and independent events. The question is, for any two equally likely, exhaustive and independent events A and B, probability of AB will be equal to, options are being given. We are supposed to find out the correct option. Okay, so we have two events, event A and event B, and we are being told they are equally likely. First, they are equally likely. Now, what is meant by equally likely events? We say if A and B are the two events, then their individual probabilities are equal. That is, two events are said to be equally likely if the occurrence of both events is same. Probability of occurring of both events is same. That is, probability of event A is equal to probability of B. That is what we mean by equally likely events. That is, their individual probabilities are equal. We are also being told that A and B are exhaustive events. Exhaustive. Okay. Now, if events A and B are exhaustive, it means that one of them must occur covering all the possible outcomes. Okay, that means if the events are exhaustive, that means one of them must occur covering all the possible events. Let me take an example. Let us say we toss a coin. Okay, tossing a coin, what are the outcomes that can occur? That is, either head will occur or tail will occur. Okay, we say getting head or getting tail are exhaustive because we know at least one of them will occur for certainty. So what is the property of the exhaustive events? That is, the sum of the probability of a set of exhaustive events is always 1. That is, what is the probability of getting head? That is 1 upon 2. And when we add what is the probability of getting tail, it is also 1 upon 2. That will be equal to 1. So exhaustive event is actually a set of all possible events in an experiment, and sum of their individual, when we add the individual events, it will get equal to 1. Likewise, if we throw a die, what are the possible outcomes? Either we will get 1, 2, 3, 4, 5 and 6. Okay, so this shows that getting 1, 2, 3, 4, 5, 6, they are exhaustive because at least one of them will occur. Okay, and the what we say, the probabilities of the exhaustive event is equal to 1. That is, probability of getting 1 is 1 upon 6. If I add, the probability of getting 2 is 1 upon 6, so 1 up to 1 upon 6 we will get. When we add them, we will get 6 upon 6, which is equal to 1. Okay, so the property is, the probability is, that is, the probability of a set of exhaustive events is always equal to 1. That means probability of A in this case plus probability of B will be equal to 1. Okay, first I am explaining these terms, then we will solve it. Okay, then we are being told that events are independent. So two events are said to be independent if the occurrence of one event does not affect the occurrence of another event. Okay, that is, if A event happens, it does not affect the probability of getting B event. Then we say the events are independent. Okay, if the occurrence of event A does not affect the occurrence of event B, we say two events are independent. In case of throwing a coin, okay, we know either we will get head. Let us suppose I get head in the first throw. in the second throw, let us say also I get head. If I tell you what is the probability that we will get tail in the third throw, it will remain same, it will be 1 upon 2. It does not depend upon the past, what has happened in the past. So the occurrence of one event does not affect the another event. Okay, that is the meaning of the independent events. In this case, I hope I am making it clear to you. Now, for what we call independent events A and B, the probability of both occurring is given by, that is, probability of both occurring, that is A intersection B, or we write it like this, probability of AB, it is equal to the product of their individual probabilities, that is probability of A times probability of B. Okay, so let me explain it again. Two events are said to be equally likely if both the events have same chance of occurring. In case of throwing a coin, getting head or tail, both are equally likely events. Okay, events are said to be exhaustive. Okay, we say two events are exhaustive. It means that one of them must occur, covering all the possible outcomes. Okay, again taking that very example of throwing a coin. So what is the sample space that we will get? So either we will get head or we will get tail. Okay, so we say event head and tail are exhaustive because at least one of them will occur out of the possible samples outcomes here. Okay, so possible outcomes are head and tail, at least one of them will occur. So we say H and T are exhaustive, and the property is the sum of the probability of the set of exhaustive events is always equal to 1. That is, probability of getting head is 1 upon 2, probability of tail getting is 1 upon 2. If we add them, we will get 1. Okay, then we have the independent events. Two events are said to be independent if the occurrence of one event does not affect the occurrence of the another event. That is, if I toss a coin and if I get head in the first throw, head in the second throw, and if I have been told what is the probability of getting tail or head in the third throw or tail in the third throw, so it will be here again 1 upon 2. It does not affect what has happened in the past. If we are getting head 10 times and if I am being told what will be the outcome in the 11th throw, that will always equal to 1 upon 2. It does not depend what has happened in the past. That's we say that two events are independent if the occurrence of one event does not affect the occurrence of another event. Now coming to the question. So we have two events, they are equally likely, exhaustive and independent. So equally likely means probability of A is equal to probability of B. Exhaustive means the sum of probabilities of exhaustive events is always equal to 1. Now if probability of A is equal to probability of B, plug the value of probability of A here. So we can write probability of B in place of probability of A. Since it is equal to probability of B, let us write probability of B in place of PA. Plus we have probability of B, it should be equal to 1. That implies twice probability of B is equal to 1, which implies probability of B is equal to 1 upon 2. Okay, remember this. If probability of B is equal to 1 upon 2 and probability of B is equal to probability of A here, okay, probability of B is equal to probability of A here, that means probability of A will be also equal to 1 upon 2. Now the question tells us what will be probability of A, B. So probability of AB is equal to probability of A times probability of B, which will be equal to probability of A is 1 upon 2 times probability of B is also 1 upon 2, which will be equal to 1 upon 4. So the correct option should be C option here. I hope I make myself clear and you find out this video helpful. Thank you.